Hey everyone, so today, day two of learning about lenses, we are learning to draw the ray diagrams. And I just wanted to mention we did ray diagrams before with curved mirrors. This is a little bit different because in these examples, instead of having reflection, which the light rays would reflect backwards, now we're going to see that the light rays can make it through the lens. And so the lens itself is transparent, so light rays should go perfectly through them. Similar to before, we have sort of three rays that we always draw. And really, we are able to predict the image most times by only drawing two of the rays. So with that same concept in mind, I'm going to click through here, and you should be doing the same as just press present in the upper right. And when we click through, a similar concept as from mirrors, we're going to use our ruler. And the first ray we draw is what we call the incident ray 1. So that's parallel to the principal axis and strikes the lens. Now, we're always going to use one refraction. We're simplifying it to use one, which is to draw it straight or parallel to the principal axis, right towards that middle line, okay? At that middle line, we're going to have refraction, we're going to have bending. Now, in this particular example, we're dealing with a converging lens. That's the shape of it. So what that means is that we're going to see this ray converge through F. So it's going to go inwards towards the principal axis. Okay, so right here, ray is refracted through F, and then your eye is just what you see. So that's going to help us with the image that forms afterward. The second ray that we can draw here, number 2, is incident ray 2. So this time we're going to pass through F and strike the lens. So here's that example. Again, same as before, we're using that middle line, that dashed line, as our point where bending occurs, point where refraction occurs. So we're not going to do it both as it enters and as it leaves the lens. We just choose to simplify it. The ray is refracted now principal to parallel axis, and that should seem or sound familiar to what we did with curved mirrors as well. So that looks like this. Now, we've talked about before that all we really need is this one intersection point. Once we have that one intersection, we can actually draw our image right here. Okay, so just for the purposes of doing the lesson part, I'm going to show you the third ray that we can draw. And like I was saying with curved mirrors, you can choose any combination of two, which ultimately will give you your final image. So I could draw the image now, but I'm going to draw a third ray anyways. Here, we're looking for a third ray that strikes the center of the lens. And what I'm talking about is this point O. And from your notes yesterday, this point O is what we call the optical center. So when it passes through there, the ray will continue onwards going in the same direction. So it passes just straight through. So what I would do is actually use my ruler, put it flat down, and draw the line straight through. Now, I just want to reiterate the point that I made, which is when I finally draw my image at the end, right here, I'm seeing that all three of those rays, they all three intersect at the same point anyway. So that's like my fourth step. I draw the image. And of course, our whole goal with drawing these diagrams, it's not just for the steps and for fun. Our whole goal is to predict what type of image will form over here. So we're talking about our size, attitude, location, and type. So from the size, we can see really clearly that it's smaller here. If we wanted, technically, we could measure it with a ruler as well. The attitude is inverted, right? This top point of the arrow has been flipped so that it's upside down. The location we're going to describe as between F and 2F. And finally, this type is real. So if we go all the way back to lesson 4 and 5, we talked about real images. And I said we really don't have too many examples of real images with mirrors, but here we have definitely a real image. The reason why, These are actual light rays that actually meet on the other side. These rays make it through our lens and they meet to form an image over here. So if I'm looking through my glasses, for example, the image does actually form at the back of my eye. Okay, so this we would consider a real image. As you go further through the notes, you will see there are some examples of virtual images. In other words, it's possible that these rays don't intersect, where we would have to extend a refracted ray backwards, again, representing something that's not a real light ray. So you will see that as you continue through. But I hope this example will help you to kind of get a feel for the lenses. Really, really similar. Again, just to reiterate, you can choose any two of these points to use, any two of these rays to use. You'll just find that you'll get into a good habit of using a certain two, and that should work out for you.